Okay, so for this lesson, we will talk about 1.1 indices. Over here, we will discuss about three main objectives. The first one is define an index. Second one, state the rules of indices. And finally, applying the rules of indices. For 1.1a, for the definition of an index, if a is a real number and n is a positive integer, then a to the power of n is equals to a multiplying itself n times. So here I have a times a times a, how many times? N times. Why is it n times? Because the power is n. So that is why it will multiply by itself by n times. And I have two terms that you all have to know. A over here refers to the base. Okay, a refers to the base, and n refers to your index or power. So again, I repeat, a to the power of n is equals to a multiplying by itself n times, because the power is n. (1.1b) state the rules of indices. Over here, I've listed down 10 rules. We will look at the first rule first, that is a power m multiplied with a power n. Over here, take a look at the base. They are the same bases. So if these two bases are connected by a multiplication, what I can do to the power is, it will produce a power m plus n. Now, the second rule is also a bit similar to just now. The bases are the same, and they are connected by a division instead of a multiplication. So this time, I can combine the powers by using a subtraction. So this will produce a power m minus n. So if you take a look at the first and second rule, both bases are the same. However, if they are connected by a multiplication, the power will be added. In the case of a division, the power will be subtracted. Now the third rule plays with a bracket. This time I have a power m everything power n. So it means that only my power will be multiplied. So this will give me a power m everything power n will be a power m n. Now the fourth rule is ab everything power m. Inside this bracket now, I have two terms. So this means that both terms have to be raised to the power of m. So ab everything power m will be equals to am bm. Now for my fifth rule, I have a over b everything power m. Again, I have two terms inside the bracket, and it is raised to the power of m. So these two terms will be also raised to the power of m, so it will produce am over bm. Now the sixth rule is the simplest rule, a power 0. Anything to the power of 0 will always be equals to 1. So a power 0 is equals to 1. The next rule now has a negative at the index. So if it has a negative in the index, it will produce a fraction. And it is not just any ordinary fraction, it will always be 1 over something. What is this something over here? This something over here refers to the remaining term that we have just now. So now I can write a power 1 to be at the denominator. And I can further simplify. Anything raised to the power of 1 will be equal to the original form. So this is 1 over a. Okay, this rule now is also the same like just now. It has a negative at the index. So it will also be in a form of a fraction. Not any ordinary fraction. It will be in the form of 1 over. Now, what I'll write at the denominator will be the remaining terms that I have just now, that is a power n. So I can write this down, a power n. All right, now I still have two more rules, and these two rules have fraction at the index. So if they have fraction at the index, first of all, I will take a look at the denominator first, the denominator of the index first. This denominator of the index will mean it has a root. So the denominator of the index is n, so this will be the nth root. The nth root of what? The nth root of what is left just now, that is a power 1. So I can write it down. This is a power 1. And I can further simplify it. Anything raised to the power of 1 will also be the same. So this is the nth root of a. Okay, finally, we have come to the last rule. Like just now, it has a fraction at the index. So if it has a fraction at the index, it will also means that there is a root. And the denominator of that index, that is n, the denominator of the index, that is n, will be the root. So I can write it as the nth root of what? The nth root of what is left just now, that is a power m. So I can write it inside here, a power m. Then I also can further simplify it and write it as the nth root of a, everything power m. For this question, we will now evaluate 64 to the power of 2 over 3. First of all, I can simplify 64. I can write it as 2 to the power of 6. And then the power here is 2 over 3. According to my rules of indices, I have one formula that is a power m, everything to the power of n. This is similar as a power mn. So applying this rule, I can now solve. This will give me 2 to the power of 6 multiplied by 2 over 3 will give me 4. 2 to the power of 4 is equals to 16. So 64 to the power of 2 over 3 is also equals to 16. Or I can also do this. 64 to the power of 2 over 3, instead of writing it as 2 to the power of 6, I can write it as 4 to the power of 3. 4 to the power of 3, and then the power is 2 over 3. Now, applying the same rule of indices, I also can do 4 to the power of 3 multiplied by 2 over 3 will give me 2. So 4 power 2 is also equals to 16. Two different ways for us to consider over here, and both methods are correct. For question number 2, I have 2 power n multiplied with 8 power 3n divided by 4 power 5n. First of all, we will check, are the bases the same? These bases are not the same. However, there is a connection between these three bases. 2 can be written as 2, 8 can be written as 2 power 3, 4 can also be written in the form of an index, that is 2 power 2. So now I can write 2 power n multiply with 8 is also 2 power 3, and then the power is still the same, divide by 4 here can be written as 2 power 2, give it a bracket. The power is now 5n. Now this is 2n multiplied with this over here. I have the properties, I have the rules, index rule, that is a power m bracket with power n. This will give me a power mn. So this one here will give me 2 power 9n divided by 2 power 10n. So now if I check, all my bases are now the same. Since my bases are the same, if it is multiplication, I can actually apply this formula, am multiply with an equals to a power m plus n. So now this is equals to, I can do the first one here, this is equals to 2 power n plus 9n divided by 2 power 10n. 2 power n plus 9n will give me 2 power 10n divided by 2 power 10n. The bases are the same, and then if it is division, I can now apply the formula am divided by an equals to a power m minus n. So now applying this formula, I will get 2 power 10n minus 10n. This is equals to 2 power 0. And I have one of my formulas, that is a power 0 always equals to 1. So any number power 0 will always be equals to 1. Okay, for this question, I'm going to evaluate negative half everything power 3. So first of all, because there's a negative symbol inside the bracket, I will raise it so that it is next to the number 1. And now I can write this as negative 1 over 2 everything power 3. This is in the form of the rule of indices, a over b everything power m, and this is equals to am over bm. So now I will get negative 1 everything power 3 divided by 2 power 3. Pressing a calculator, negative 1 everything power 3 will be negative 1. 2 power 3 is equals to 8, so the final answer is negative 1 over 8. For question number 4, we are going to evaluate 8 over 27, everything to the power of 1 over 3. It is in the form of a over b, everything power m. So this will give me a power m over b power m. So now I can write this as 8 power 1 over 3 divided by 27 power 1 over 3. What can I write about 8? 8 is actually 2 power 3. The powers outside remain the same. And this 27 here can be written as 3 power 3. And the power outside is still the same. So now solving it, I'm going to get, and over here, before I continue, you will see this pattern in one of our rules of indices where I have bracket a power m and then the power outside is n. This one will give me a power mn. So applying this rule, I'm going to get 3 multiplied by 1 over 3 will give me 1, so 2 power 1. Divide with, over here, I can still apply the same formula. I can still apply the same rule. So this will give me 3 power 1. And last step, anything raised to the power of 1, I will get back the original form, that is 2 over 3. Okay, when multiplying powers, we only multiply the power. So 3 times 1 over 3 will give me 1. And then 3 times 1 over 3 here will also give me the 1. Okay, for question number 5, we're going to evaluate 27 over 8 to the power negative 1 over 3. Before we continue, we try to recall a property, a rule in our index. If I have a negative symbol, so now the rule is a power negative n. If I have a negative, automatically I have 1 over something. 1 over what? 1 over the remaining term, that is a power n. So I'll put this a power n down here. So now I'm going to apply. Okay, I have a negative here. So I'll get 1 over something. 1 over what? I will get 1 over what's left here. 27 over 8 to the power 1 over 3. This whole thing will be at the denominator. So I'm going to write it down, 27 over 8 power 1 over 3. Now the numbers 27 and 8 are very familiar. Something that you should remember also, it will help you. 27 can be written as 3 power 3. 8 can be written as 2 power 3. So now the whole thing, power 1 over 3. Okay, we take a look at the numbers here. Do you see a similarity? Check the powers. Both numbers, they have the same power. Okay, both numbers, they have the same power. So in that case, we have one formula, AM over BM. In our property, in our rule, we actually have A over B, everything to the power of M. If you see our property, we have A over B, everything power of M, to be equals to AM over BM. These two things are the same. So now I can change it and write it as 3 over 2, everything power 3. And then after that, I have another power outside, that is 1 over 3. So I can write it here. Now this is in the form of this property, that is A power M and then power N outside, which will give me AM N. Okay, this is my A, and then this is my MN. So now I'm going to apply. This will give me 1 over 3 over 2. 3 times 1 over 3 will give me 1. So anything raised to the power of 1, I will get back the original form. That is 1 over 3 over 2. 1 divided by 3 over 2 will get 2 over 3. Okay, for question number 6 this time, we see two small numbers here. These two small numbers here refers to the root. Okay, we have A 1 over N. If I have a fraction as my power, I am going to look at the denominator. And the denominator over here is N, so this one will give me the nth root. The nth root of what? The nth root of what is left, that is A power 1. Which is equals to the nth root of A. So this time, do you realize that this number, the third root of 4, is in this form? And then the fourth root of 2 is also in this form. So I can actually change the shape. So what I can do now is, I'll be able to get 4 to the power of 1 over 3. I'm going to change it to this form. Okay, the third root of 4 is also equal to 4 to the power 1 over 3. Everything power 2. And then here is 2 to the power of 1 over 4. Everything power 3. So looking at the pattern this time, this one is in the form of A power M power N, which will be A power Mn. So now I can write this as 4 to the power 2 over 3 multiply with 2 to the power of 3 over 4 using the same formula. So I see my two bases now, and I realize that my two bases are not the same. I have 4 and 2. However, there is a common factor between 4 and 2, and I can also change 4 because 4 can be written as 2 to the power of 2. Here is 2 over 3 as the power, and this is 2 to the power 3 over 4. Again here, it is still in this form, so I can apply. So now I will get 2 to the power 4 over 3 multiply with 2 power 3 over 4. So at this line, if the bases are the same, I can apply this rule, that is A power M multiply with A power N to be equal to A power M plus N. Okay, I'm going to get 2 power 4 over 3 plus 3 over 4. Since the bases are the same. And since this one is a multiplication, I'm going to plus the power. So now solving it, I will get 2 to the power of 25 over 12. Okay, now for question number 7. Question number 7, we will play with the rule where I have AB power M. So this means that whatever inside this bracket will be raised to the power of M. So I'm going to get A power M, B power M. So now what I'm going to do, continue, I will have A power -2. This whole thing will be raised to the power of -3 also, as well as this thing. So this is B power -1 raised to the power -3. Now we check the denominator, and it is equals to, and then it is the same as A power -1, B power -1. So next I'm going to check. I have over here, I have the property A power M raised to the power of N. This will give me A power Mn. So it means that I'm going to multiply my powers. Now I'm going to get A to the power of -2 times -3 will give me 6. So A power of 6 multiplied with B power of -1 multiplied with -3 is going to give me 3 over A -1, B -1. Okay, what am I going to continue next? I see that I have A at the numerator and A at the denominator, as well as for B at the numerator and at the denominator. So I'm going to play with this rule in indices where I have AM divided by AN. AM divided by AN actually can be written in this form also. It has the same meaning. And then this is equals to A power M minus N. So now I have A power 6 minus -1 and B power 3 minus -1. So solving it, I'm going to get A power, negative is a positive, and then here, negative is also a positive. So finally, I have A power 7, B power 4. These are some questions for you to try. You may pause the video while attempting these questions. These are the solutions to the questions just now. Now we've come to the end of the lesson. I hope you all understand this subtopic, that is 1.1a, b, and c. Thank you very much.